I am going to explain about moment generating function. Actually, MGF means it is an averaging process for random variables. It is an averaging process in special case. For example, if we take one company data, here I am taking in the first day they are designed 10 bolts, and the second day they are designed that is 20 bolts, and third day their design that is 30 volts, and fourth day their design 35 volts. Like this, if the data is varying like exponential shape, just assume it is an e power tx. So then, so here, then what is an average? So the for that they have given that is mx of t is equal. Of course, it is also denoted with e power tx, exponential of tx is equal minus infinite to plus infinite e power tx f of x dx, f of x dx. So this is for continuous random variable average. For discrete random variable, that is exponential of e power tx equal sigma I equal 1 to n e power tx p of x, probability of x. This is for discrete random variable average. For discrete random variable average. So finally, MGF means it is an averaging process and also named as it is an highest moment. Highest moment. So for this, you will go with one example. Here you can see this. This is an highest moments e power tx. So for continuous random variable, we can write it as minus infinite to plus infinite e power tx multiplied with f of x dx. This is for continuous random variable. If it is discrete random variable, we have discussed this is for continuous random variable. We discussed already. If it is discrete random variable, sigma e power tx into p of x dx. So you will go with one example, and if f of x equal to 2 minus x, here you can say this f of x is equal to 2 minus x from the limits 1 to 2, then find MGF. So according to the MGF moment generating function, the highest average can be defined as that is minus infinite to plus infinite e power tx multiplied with f of x dx. This is for continuous random variable, and limits already given that 1 to 2. F of x means 2 minus x and multiplied with e power tx dx. So separate the third terms, that is equal 1 to 2. 2 into e power tx minus integral of 1 to 2 x into e power tx, x into e power tx. Then 2 is a constant, e power tx integration is e power tx by t of the limits are from 1 to 2. This is the first term completed. Then this is an x into e power tx, that is I am assuming this is uv formula. Integration of uv is equal uv dash minus integral of u dash v dash. So let I am assuming let u equal to x. So from this u dash equal to d by dx of x is equal derivative of x equal to 1. I am assuming v is equal e power tx. So therefore e dash v dash implies that is equal integral of e power tx. So that is equal e power tx by integral of t. So this is an v dash. So from this we can write it as u v dash minus u v dash minus integral of u dash v dash. So we will write it u means x, v dash e power tx by t, e power tx by t of the limits are from 1 to 2 minus integral of u dash. U dash means you have seen that derivative of x, that is equal to 1 e power tx by t of dx. of dx. The limits are from 1 to 2. So this is equal, substitute the limit 2 e power 2t by t minus lower limit is 1, 2 e power t. In the place of x, you are substituting. So this is the first term completed. Minus, substitute the limits in the place of x, 2 into e power 2t by t minus 1 into e power t by t. So this is the second term completed. Next third term, again e power tx by t, integration is e power tx by t square of the limits are from 1 to 2. So therefore, write it again, 2 into e power 2t by t minus 2 into e power t by t minus 2 into e power 2t by t minus minus plus e power t by t, e power t by t. Of course, this is totally uv from here to here. So this is minus and this is minus of minus plus, and this is again plus minus into minus. Substitute the limit 2 into e power 2t by t square minus minus of minus plus, plus into minus, minus of e power t by t square. So this is the final. So if any simplification is there, we can do it anyhow. So for example, this 2 into e power 2t by t and plus 2 into e power 2t by t will cancel. So again, if any simplification is there, we can do it. We need to do it. So like this, we can find the average for moment generating function. Thank you.